Good morning students, hope all are good. So today we are going to see about an interesting lesson in physics which is gravitation. Okay, so before that let me tell you a story about a person, then we can start our lesson. Okay, so there was friends which were just playing and they was enjoying their life in a college life. So that time there was a subject which was a subject. What was the subject is a physics related physics subject, which is a motion of a planets and motion of a moon, motion of the body, which is a satellite or orbit which is revolving. Okay, so this was an interesting subject. Among them, one person, a major person, which is a Sir Isaac Newton. So Sir Isaac Newton was also a students among them, and then they were an interesting lesson or a subject which of the physics they was learning. Okay, so that time what happens? There was a severe deficiency, which is a disease called a plague, was spreading. Now there was a COVID, no, it is spreading, right? So same that in 1665, a plague infection also was spreading severely. Okay, since it was spreading, no, that time all the colleges were closed for a certain time. At that time he was just worried about the concentrating on the subject. He went to a park and a garden. He was sitting under a tree and playing with the friends. At the time he saw a plant, a tree, where an apple tree, no, so it was just falling down. Okay, so by seeing that, Sir Isaac Newton was just he was just observing why it is just falling down, what makes that apple to fall down. So from that only he came to know about this gravity. Okay, so the attraction, gravity is nothing but an attraction. So this is what Sir Isaac Newton found, that the gravitation is present all over a place. Okay, so this is what we are going to learn briefly in now. Okay, so gravitation is nothing but a attraction. So attraction is something, it is attracting, pulling, no? So that is known as a gravity. Okay, so how this gravitation is telling here, the definition is the force that attracts all objects towards one another. The force, no, the attracting is also a force. So the force that attracts all other object one another. So if I'm just standing, if you're just keeping any, don't take me as an example. If I'm just taking any object which is a magnet, just assume this as a magnet and this as a safety pin. So if I'm just bringing back near to them, it will be attracting. Have you seen? So that attraction is nothing but a gravity, the pull between the two objects. So it will both objects will be attracting. No? So that is known as a gravitation. Okay. So example in your daily life, apple detached from a tree. Detached is just falling or pulling. Okay, so if an object, if I'm just scraping a chalk piece, I'm just leaving. Okay, so it does fall down. So because of gravity, so something, the earth is just observing or attracting or pulling something, the object which is present in a so if I'm just throwing a ball, it will just, does it just place direction, it will come down, no, it will come down. Something is pushing from up, no, it is automatically is coming down. So because of the attraction of the earth. Okay, so this is all the example. Then a ball, then rainfall is also an example for gravitation. So rainfall is just the water is pouring from a top. So we won't just pull that rainfall or droplets, right? So automatically done by the nature. So that pull is known as a rainfall. Okay, then planet. Now you may ask, does the planet also have some gravitation, which means attraction? Now my question is that. Okay, so what you are saying, either it is yes or no. Does the planet having a gravitation? Absolutely, it is having a gravitation. Because of that only all the planets are revolving around the sun. Okay, so the sun is also having a gravitation and other planets also having a gravitation. Because of that only the planets are revolving one another. Okay, so this is what the gravitation says clearly about that. So what is the gravity? Gravity is nothing but an attraction. So attraction, pulling between two objects is a pulling means just attracting. Okay, so that attraction is known as a gravity. gravity. So what is the force? For example, if you need to know clearly means, if I'm having if you just having a tied a thread with a hand or a finger, okay, one end just tie with a coin or some other ball, metal ball, just rotate. So if you are rotating, no, there will be some force. Why can't that metal ball can move from here to there, there to here, no? So why it is moving in a circular path? Because the force is here, it is making the object to revolve. So there is an attraction between my finger and the metal ball. So that only the object is revolving. The same, the planet also having the attraction. So that only it is revolving on the orbit. Okay. Then how it is, if I am just asking you, it is a apple detached from a tree. So that same, it is a pull, that is attraction which is done on the earth. So that is also an example for the gravity. Okay, then the force that attracts all the object towards another. So one another, if it is attracting, we will be coming to know that it is a gravity. Okay, so then we are moving to a fact about the gravity. What are the fact in the sense? It is a truth about the gravity. So today we are going to see about a full topic about just a simple thing, a gravity. Okay, so what we saw first, we saw what is the definition for gravity, what are the story about the how it came, how the gravity is observed, how it is initiated by them, who it is initiated. It was initiated by the Sir Isaac Newton. Okay, so he was the first one to initiate the gravitation. So we learned about them, what are the definition and what are the examples. Now we are going to see about that facts about the gravitation. So earth is spin around the sun. So because of the gravitation only, earth is revolving the sun. We know, right? So same growth of plants and vegetation. So now you can clearly observe that if you are keeping a plant inside a shady thing, in some shady part, the plant will automatically move and it will turn towards the sun. Wherever the sun light is just, the plant will also move because of the attraction. So attraction in the sense the sun is having a gravity. By the gravity, the plant also is absorbing, attracting and it will move towards the sun. So there is also a gravity present in the growth of the plants. Then sun's gravity. So sun is having a gravity, we know, right? So sun has a gravity, that because of the sun's gravity only planet is revolving the sun. Okay, so because of the gravity of the sun only planet is revolving the sun. Same, you may ask, only sun will be having a gravity, not a moon, ma'am. You will be asked to know. All the planet, including moon, everything will be having a gravity. Okay, so that gravity is a present here. So now what are the things which is done, you will know. If it is absent, what are the things will be happening, we will see. Okay, so absence of gravity. In absence of gravity, what will be there? We will float and fly. So you know what is the astronaut? No, you know who is astronaut. They will be going for a going on a space and they will be researching, right? So that astronauts, what they will do, no, if there is a less they will be moving away from gravity. So they are moving away from the earth. So earth is also there will be some amount of less amount of gravity will be appeared. Then that time only all the astronauts will be floating. Have you seen? You will be seen, right? It's because of that lesser gravity only we will float. If there is no gravity, we will be floating. So there is no air. That's what will be taken. Okay. Then 12% of lesser gravity satellites may float away. So the orbit and satellites which is revolving, no, if it is a what is it, 12%, if it is in case it is a 12%, it is less, means the gravity is what less, means the satellites also, even the satellites also float away. So if we are floating, the satellite float away, we don't ever get a correct signals. Okay, so that is also a big drawback. Absence of gravitational pull on earth. So absence, if there is a gravitational pull is absent there, rainfall, snowfall may be absent. So if there is a gravitation pull absent, something is gravitation means something, attraction is less, means how the rainfall will fall down, how the snowfall will fall down, how the waterfall will fall, it is absent, no? So because of that only it is gravitation pull is needed. Then no pull done on earth. So it is, if I am standing now, if there is no gravitation, I could not stand, I will be floating. So there is no attraction between me and the earth. So that earth will be attracting. Can you understand? So because of the gravitation is very important, because on a daily life, okay, so without gravitation we cannot be. It is very difficult to live. Then this what, if there is an absence of gravity. Absence of gravity, pull on earth, rainfall, snowfall may absent. This is what we say, it is a basic thing, it is needed. Since it is not just a part of, we don't think that is a part, but if at all 12% is less. See, satellite also can float, then what about us? So this is what it will be very important. Okay, so that's what we'll be saying, clearly seen. So what is that? Gravitation is nothing but an attraction. Attraction in the sense it is a force between what? Earth and iron. So now you may ask, only human beings, ma'am? No, even non-living things also, even a thing. What is non-living thing? Living thing, everything has a gravity. Because of gravity only, object will be staying in the same place. Okay, till that are we clear? What is the gravity? What are the examples which is used in daily life? What is the thing we use in the gravity? Now we are going to see about that universal law of gravitation. Okay, so universal law of gravitation, the word itself says that gravitation is initiated by the Sir Isaac Newton. Okay, so he was just observing the gravitation by the sense of he was in the leaf. Okay, so he was in the leaf. That time he saw a apple detached from the tree. Okay, as I said before, the same story. So the why the Polygemus was given a leaf means there was a huge disease spreading plague. Okay, the plague which is spreaded by the infectionated rat. Okay, so rat or any other animal. So if it is infectiated and then it has got a bite, and then that animal which is spreading, no, that disease will be called as a plague. So that plague is a very dangerous and it will be spreading all over our body. It is not easy to say, it is very dangerous for our human beings. Okay, so that time only there was a huge leave given, and that time you found the gravitation part. Okay, so now we are going to see about that universal law, which in the sense a rule, how it is a formula, it is derivated, how it is taken up. We are going to see in brief. Okay, so gravitation, universal law of gravitation. So initiated by Newton in 1687. So the plague which was spreading, no, it was in the year 1665. After that only, it is 1687 only, he initiated the Newton's law, which means the gravitation law. Okay, so after that only he initiated. What he was just deriving in the sense, the gravitational force between two bodies is proportional to the product of the masses and their inversely proportional to the distance between them. So what is saying is the gravitation force, the pulling force, no. So that is done by the two bodies, which is opposite bodies, which is proportional to the product, which means the mass, the weight of the object, and inversely proportional to the distance between them. So the force which is taken up by the gravitation is done between the two bodies. It is directly proportional to their masses. So it is based on the masses and then inversely proportional to the distance. However, the distance is separated. So that only takes up the masses and the distance between the two objects by the force. So this is called as a universal law of gravitation. So how the gravitation constant is saying is, so they have taken up a derivation which is a formula they have taken up from before. So what is this? F is equal to capital G m1 into m2 by r square. So the m1 and m2 is nothing but mass 1 and mass 2. So I will write here m1 and m2 is mass of the object, and then G is the gravitation. So I have written here, no, capital G is the gravitational constant and R is the distance. So R is the distance between the two objects. So for this to measuring the gravitation, we need two masses, mass 1 and mass 2, for just knowing that, and then R is the distance between the two objects, and the gravitation constant is the capital G. So all together we will be calling as a force, which is an F. So this is what the gravitation says the derivation. Okay. So then now I am going to take about the two object which is a ball. One I am naming it as a mass 1 which is m1 and mass 2 it is m2. So I am going to just move towards, I am going to push the ball towards each other and then I am going to measure the distance. So the distance is taken up into a d. So before taking up the value, just come here and mass 1 and mass 2 are taken up 1 kg. For example, I am just assuming mass 1 and mass 2 are taken up 1 kg and then r which is the distance which is 1 meter. So the distance which I am taking is 1 meter. So then if I am substituting, so now this 2 part will be substituting here. If you are substituting, what will happen? F is equal to G, then what is the m1 and m2 are taken? 1. So it is a 1 and then r square is 1, it is same as 1. So all together it is a 1. So it is now, then it will be taken up is equal to F is equal to G. Okay, so this is what the gravitation, universal law of gravitation says. Okay, then the constant value, we need some constant value to derive the universal law of gravitation. For that I am going to take a value which is a constant 6.67 into 10 power minus 11 Newton per meter square kg per meter square. So this is what the value of universal law of gravitation. Okay, till that they are clear. So let me just go through what I said before. Now I am going to take about the universal law of gravitation which is enunciated by Newton's in 1687 after the plague. So after the plague disease only he have just enunciated there is a law of universal law of gravitation, and then he gave a derivation or the explanation about the universal law of gravitation which is nothing but a gravitation force, a pulling of force between the two objects. So the object is nothing but a body also. It is proportional to the product of their masses. So the multiplication of the masses and inversely proportional to the distance between them. So it is opposite to the distance between them. Then come to gravitation constant. So I am taking up a constant value which is F is equal to G into m1 into m2 by r square. So G is nothing but a gravitational constant. Then m1 and m2 I am just naming it as 1 kg and r which is listed that nothing but a distance which is 1 meter. Then if I am substituting all together it will be getting 1. So F is equal to G. So this is what a universal law of gravitation is. Very simple. So this gravitation is a very interesting lesson. So if you just listen, you will be into that lesson. You no need to mug up. Okay. So next we will be seeing about an interesting topic. Now we are going to see about an interesting topic which is a satellite. Okay, so satellite, we all know what the familiar word it is, a satellite, right? So it will be revolving around the earth. We used to learn in the lower class, right? So satellites, what are the process? What is a satellite? What are the types and what are the uses? Only we are going to see them. Okay, so satellite is nothing but it is a planet. It is a moving planet. So moving orbit around the planet. So it will be moving around the orbit in a planet. So it will be moving around the planet in an orbit that is known as a satellite. So there will be some particular line. In that line only the satellite will be revolving the planet. So if you see in some things when they will be showing that Earth, if there is Earth, around that it will be the revolving. So like this it will be revolving. Just like a rectangle shape, it will be just bottom, it will be a circular, and then side it will be the plate which is a solar. It will be just spinning around the earth. So that is a satellite. So it is revolving the orbit on the earth. Okay. So what is a satellite means? It is a moon is also a natural satellite of the earth. So we call a moon is a natural satellite of the earth. So how it is revolving, what time it is taking to revolve the whole thing means it taking the 27.3 days, which means 27.5 days. Okay, so it takes that days, 27 days to revolve the earth. Okay, so this is what the satellites will be taking time to revolve. So what are the types of satellite means? A satellite is two types, which is geostationary satellite. So geostationary satellite in the sense we communicate. There are a lot of communicable devices has improved, technology has improved. So we'll be just calling even when they are in a part abroad or some other thing, wherever they place, we just make a call, we'll be talking with them, right? So because of the satellite only, we are used to call easily when they are on long distance, okay? So the communication of what we need, this is done because of the satellite. So it will just travel the signal and it will be passing to us. So not only mobile phones, ma'am, you may ask, no, it can travel, it can just communicate everything. So that communication devices will be all together will be coming in a geostationary satellite or synchronized satellite, which means together, synchronized together satellites. All the communicable devices will be done in a synchronized satellites. Okay, so then polar satellites in the sense it will be revolving on the north to south pole. So that there will be Earth, no? If this is the Earth, there is a north pole and there is a south pole. The polar satellites, how it will be revolving, no? It will be moving here, then it will be going back and then coming again and then so north to south only it will be revolving. Okay, so this is what it will be programmed. So it won't go here and there, it will be just moving from the north to south. So this is the process, it is done only by the polar satellites. Excuse me. Uses of satellites. So what is the uses? What you may ask me, the satellites is nothing but to communicate. It is help us to communicate, it is doing all the things, right? Okay, so what is the main thing, what is the work that satellites need to do? We will see, okay? The uses of satellites is nothing but a communication. So for communication purposes only, the satellite has initiated. So how it is communicable means in the radio. So you may you'll be having a radio, no? So in your phone itself, you just plugging on your headphones with automatically the radio will be on. You will be able to hear all the songs, right? Then televisions, mobile phones, and all the things, what are gadgets you're using, electronic gadgets will be coming under communication, which is the uses of satellite. Because of the satellite only, we may able to just know all the things, right? Then telephone signal. So even now we don't use a telephone, but those days they will be using a telephone now in the wire plug, right? So because of that only, the signals has done and it is traveling to a other person. So they may just communicate easily. So because of the satellite only. Okay. So next, weather monitoring. So we know well how they will be, even daily you will be knowing. Morning this weather will be there, afternoon it will be changing, it will be raining or it may have a storm or it will be sunny. We will be able to just say before the day begins, right? So because of the satellite only, we will be able to know what are the climate, weather, earth is changing. So even in your phone also, if you're just searching, no, it automatically it will notify the weather app will be on, it will be a default. Okay, so you may see that till the timing also you will be seeing. So 6 to 9 it will rain, then 9 to 10 it will be sunny, and then it will be rainy or stormy or it will be windy. Everything will be given in detail. So because of that only, the satellite only, this weather monitoring, it is used by the satellite. So because of the satellite only, we will be able to know how the weather is going. Okay. Then amount of heat radiated. So even same whether it's coming under the heat radiation only. So even there is a high amount of sunlight is there, means or it is so sunny or it is less sunny, everything will be detailedly saved by satellites because of that only. And then remote sensing in the sense, if I just need to call some other place who are above from that, I need to call, no, so every physical contact will be done by the remote sensing. So because of the remote sensing only, we may able to just communicate or what are the physical tasks they are doing, no, everything will be noted down by the remote sensing. It is just, for example, if you are just going in a hospital, they will be monitoring all the things. So if I'm just, okay, now I'm just taking lesson, if I'm going home, no, I can easily operate here what is going to happen in a school. So I'll be operating with my devices. So that is a remote sensing. Okay, I'm not here, but I can do my work when I am in a home. So work from home they'll be taking off. So because of that satellite only, we will take that remote sensing also. Okay, then navigation satellite. Navigation in the sense, the movement, how to move, what are the things should be done, what are the place it should be shifted, everything will be done in a navigation. For example, a ship is there, you will be traveling in a marine now. So that ship, no, if there is a something is going to happen in a sea, that also will be just notified by the navigation satellite. So that also will be just notified. So something is going to happen in the sea. So you should be alert. Or they'll be announcing in the news. No. So this time you should not go to the sea. It is very dangerous. So there is going to be happen a cyclone or something. They will be announcing. So how they are announcing? Do they know anything? Because of the satellite only, they came to know all the information. They will record and they will be collecting and then they will be intimated to us. Okay, so then this is what the uses of satellites are telling. So just in general, okay. So what are the first? It is a communication. Communication in the sense radio, television, and telephone signal. Not only telephone signal, even now we are using mobile phone also. It is done by the satellite signal. Okay, so the signals is passed to one person to another person. That is what it is. A signal is nothing but a satellite. Weather monitoring, that is a weather also, and amount of heat radiated means nothing but a weather. What is the weather we are going to take up today? It is going to Sunday means everything will be detailedly said. Even each time also time also it will be said cut and clearly. So then remote sensing in the sense I will be at any places, but I can just operate everything even when I am not in the place. So that is meant by the remote sensing. Navigation in the sense is meant by the ship. So even if you are going to the ship also, they will be just notifying you should not go, that there is going to be happen, storm or cyclone will be going to happen. Everything will be done by the navigation satellite. So it will tell all the details. Then come to escape speed. Escape speed is nothing but if I am going to just I am going to throw an object. So I am going to throw in this chalk piece. It won't stay in the same place, right? So it will go to a certain amount. How much force I am giving, that much force it will be going up and it will reach a distance and then it will come back. So it will just escape from the air and it will just go from the earth and then come back. So that is the concept is known as an escape speed. Then there is a definition given here. A body or object is 11.2 km per second. So a body or object. So if I am just throwing an object and then throwing an object about earth. So what happens? The object or object is, I am just throwing, that is 11.2 km per second. So it is moving from here to there 11.2 km per second. Then the gravitational speed is the minimum speed. So gravitational speed is a minimum speed. So it is not so maximum. It is just a short speed in which a body be projected. So how the body is projected, that only we may able to just move the calculator speed, and greater than it may be escape from the gravitational pull of the planet. So that time if I am just throwing, that time it is just escaping from the earth and the pull gravitation and then reaches the air and then come back to the same position. So this is called the escape speed. They have given derivation which is an velocity of an electron which is equal root of 2 gravity of distance. So 2 gravity of the distance in the sense they are taking this derivation by this only the escape speed is just innovated. Okay, then they are giving some planet if I am just throwing if an object is in case if the planet is just moved from a gravity, how much amount or how much kilometer does it take to be in escape speed and it comes back. The 3 things they are given rod. What is that? Mercury it will be taken for a 4 km. So 4 km per second it will be just moving in the escape speed and it will come back. Okay. Then it is mainly not we are not assuming it is a thing the mass of the object. Okay. So the Mercury is small, so it will be taking as a 4 km. Then Jupiter is little bigger, no, so it will be taking us a 6 km per second, and then Moon will be taking us a 2.5 km per second. So this is what escape speed will be done in some different planets. Okay, so this is what the gravitation tells clearly about us. So what does that mean? Satellites is nothing but a moving orbit around the planet. Moving orbit around the planet. So there is an orbit which is moving around the planet, that is known as a satellite. Moon is also called as a natural satellite of the Earth. So this is artificial, but the natural satellite is nothing but a moon. So moon is a natural satellite of the Earth, and then it moves around the 27.3 days. So it is moving around the Earth for 27.3 days. This what is the satellite says. Then come to the tides. Tides is nothing but geostationary satellite. Geostationary satellite is nothing but all the communicable disease, all the communicable devices will be done in a geostationary satellite. Okay, so whatever you're just communicating, or it can be a mobile phone or telephone or some other television, everything will be giving us some ads. No, all the things will be just telecasted because of the geostationary satellite. Then come to polar satellite. Polar satellite is nothing but it will be moving only in a polar, north to south. That is a revolving. That is known as a polar satellite. Then uses of satellites. Uses of satellites is nothing but communication between us, or communication in the sense it is a satellite. So what are the communication needed? Radio, television and telephone signals. So all the signals, what are the things we need to communicate, no, that will be coming under the satellites, use of that. Then weather, you will be knowing all the details of the weather, whether it is rain or summer, whatever season, everything will be told by the satellite. And the remote sensing also, even if I am not in the same place, I can able to just do the things even when I am in a home. So because of that remote sensing only, I can do this work. Then navigation in the sense, if your navigation in the sense it is a ship. So even if you are going submarine or some other big ships, even if you are getting some other thing, it is done by the navigation satellite. Then come to escape speed, a body or object in the 11.2 km per second. So if you are throwing any object or a body, that will be coming under the 11.2 km per second. Okay. Then they are given a definition. What is that? A gravitation speed means it is a natural speed. So the speed is a minimum speed. It is not going so far. It cannot go from there to here, one place to other country. It is a minimum speed which is taken up by a body and it is projected. So it is projected by the rather than any other object from escape. It is escaping from one object to the another object and it is returning back with a gravitation pull. Because of the pull only it is coming back to the same place on the earth. Okay, so this is what they are given, and they are given a three planets, which is Mercury, Jupiter and Moon. Mercury, if you just attaining at the escape speed, it will be taking about at 4 km per second, and then Jupiter is 6 km per second, and the Moon is 2.5 km per second. So this is what the gravitation lessons tells about you clearly. Okay, so just learn, understand what I am saying, go through what is done here, and then come back. We'll be just meeting with a new topic in next lesson. Okay, thank you students.